In this video, we're going to explore positive and negative feedback in terms of physiology. So many molecular and physiological processes are controlled by feedback mechanisms. There are two types of feedback mechanisms that we're going to talk about. The first is positive feedback. It's when the rate of process works to increase a product. We can think of this as a domino or chain effect. So the process will work to increase one product, which will then go ahead and stimulate the production of another product, and so on. The opposite is negative feedback, or when the rate of process has to be controlled to prevent the accumulation of a product. Negative feedback works to decrease a product. So that's important because if we have an accumulation of a product in our blood, for example, we can't have it build up to excessive levels. That could be really toxic. That's why negative feedback mechanisms are put into place to control the process that's increasing the product. So it will work to inhibit that process by decreasing the product. Let's look at a physiological process that uses positive and negative feedback, and more specifically occurs in females. So the first structure here in blue is called the hypothalamus. The hypothalamus, as you may have heard in your studies, is the master control gland of our endocrine system. Now it signals, or basically talks to, this next gland here, the pituitary gland. The pituitary gland is further broken down into two lobes. The back lobe is the posterior, and the front lobe that we're going to focus on is the anterior pituitary. Now, moving down, we have another organ called the ovary. So females have two ovaries that are located way further down in the body, while the hypothalamus and the pituitary gland are up in the brain. Now, I've also color-coded these four hormones that we're going to talk about, so that way we can keep them straight as we go through the process. The first is estrogen. The second is GnRH, or gonadotropin releasing hormone. The third is LH, or luteinizing hormone. And the last is progesterone. So let's start. During the menstrual cycle, and more specifically before ovulation, small amounts of estrogen are secreted from the ovaries. This small amount of estrogen is just enough to trigger the release of two other hormones. So it stimulates the release of GnRH from the hypothalamus and also works to stimulate the release of LH from the anterior pituitary. So this is an example of positive feedback because the process that stimulated estrogen also stimulated the release of GnRH and LH. So GnRH can also then work on the anterior pituitary to stimulate the production and release of even more LH into the blood. So here's positive feedback again. The hypothalamus communicates its message down to the anterior pituitary. Now LH can also go ahead and stimulate the release of even more estrogen. Again, positive feedback. So here we have a cycle. Estrogen causes the release of GnRH, which causes the release of LH, which causes the release of even more estrogen. And the cycle continues. So you can see that chain effect we were talking about. So estrogen is produced, let's write that over here, which triggers GnRH, and that works to trigger LH. Now GnRH and LH are going to be accumulating in our blood due to positive feedback. So when high amounts of LH are produced in the blood, another hormone will wake up, so to say, and that hormone is called progesterone. So progesterone is triggered when it senses that these LH levels are too high, and it's secreted from the corpus luteum after ovulation. So after ovulation, the progesterone will trigger the GnRH production in the hypothalamus to turn off, and that will also trigger LH production in the anterior pituitary to also turn off. So, can you guess what this is called? If you said negative feedback, then you are correct. Since the levels of product are becoming too high in the blood, something needs to cause an inhibition of those products. That way they don't accumulate in the blood. That's why progesterone comes in and turns off that positive feedback process and decreases the products. That's where we have an example of negative feedback in this specific physiological mechanism. Going back, we can see that the LH caused the production of progesterone, or the secretion of progesterone in the first place. And then progesterone is going to go back and work on inhibiting further GnRH and LH release, as you can see in this little cycle. So that's how we maintain homeostasis, or balance in our body, which is really important for maintaining molecular and physiological processes. That way nothing in our body becomes too out of balance, too high, or too low. That's the beauty of physiological feedback.